Right, let's get this started. How are all you doing today? This has been quite a week, hasn't it? This is the fourth day I think I've been streaming. There was a quick break on Wednesday. There's some fun that we'll talk about a little bit later, but this is the show. So we are at episode 4, and I've got the black glove ready to go. So there's going to be some drawing. Yeah, it's as decent as it can go. What's up, Nightshade, dude? And thanks, Cam, by the way. Yeah, we finally made Twitch affiliate. Okay, so we're going to talk about a bunch of things today, but let's just start off. The mana bar is currently having some issues, so I'm going to have to operate without mana, which I'm not a big fan of. But, you know, it's just one of those things that... There was a hosting bit of fun. I'm not going to name the provider, but some very large cloud provider decided to change things about my hosting arrangement. Let's just say they changed the terms of service, and they just kept putting it in just about every browser I ever saw. And the funny catch of that is that I could no longer push coding with some guy briefly. So that led to a lot of interesting things as we were getting ready for some of the stuff this week. So long story short, Linode to the rescue, and I got to have fun manually remembering how to do SSL TLS certificates again. I'm not proud of it, but you know, we're there in the meantime. We're back up, and it broke things a little bit with the mana bar. So I'll get that fixed for the next show. But you get to watch me put it together in the intro anyway. So business aside, you already know we have our bots up and running today. So you can actually come join us in the Discord if you're new here, or if you're like these other dudes, you already know where it is. And if you can't find that, then, well, I mean, this is a programming stream, so it might be a little tough to follow for some of the live coding, but I'll do my best. So what are we doing today? Today is going to be about PKI, and specifically, we're not gonna talk about like pure public X509 and all that magic. Instead, today we're going to talk about something that comes from an older era. This is originally stemming from Pretty Good Privacy, or PGP, which later got built up by GNU, however you happen to say it, into GPG, which we're going to be using today, and we're going to be doing that programmatically, which is a little different from how you normally may use it. So we're going to work with that. We're going to generate. That's why I need all those dice. I mean, we're going to be working with entropy like nobody's business, and we're going to be tracking that entropy as we're moving around. So without further ado, I think we're going to need to get serious with signing. We're going to get serious. We're really going to be worried about signatures and verification more than cryptography, but understand that the same technology is going to work for both with some variations. If things go well, we're going to get to pixels. We're going to be messing around with things you probably shouldn't do to a PNG file, but I think we're going to do those things. So we're going to see how far we get with the live coding with what we can do in an hour. So yeah, let's just do that.
Telling me that instead of writing code myself, I could watch some guy write code?
All right. Well, breaking stuff aside, I think that this is going to be kind of a fun episode. So we're going to mess around here today with GPG, and we're going to be doing that I can spell too. It's one of my latest talents. We're going to be working with GPG and Python, and we're going to do a little bit with the shell depending on how we get there. And the way we're going to break that up color-wise is we're going to start off just kind of exercising the code. So in particular, this is, we need to work with, we need to make a vault of sorts. Now, this is not the same vault that you might have seen on the Alt F4 stream if he happens to show up, and this looks more like an eye, but let's just pretend that this is like, oh yeah, now it really looks like a glowing eye. So we're gonna take this vault, and this is gonna be our key trust system, and we're gonna use the default stuff that works with GPG. In Python, we're gonna be using a wrapper for it, which is the Python GNU PG module, and assuming we can get all of that working, so we're going to need some key generation, and then we're going to figure out how to sign things. Well, actually, that's exactly what we're going to do next. We're going to figure out how to sign things and verify them. So once we have our key and we know that our program is able to adequately operate on this key store, then we're actually going to take all of that and we're going to start working with graphics. So let's just get crazy there. And we're going to talk about pixels. And this is the part, this is going to be more of our stretch goal, because this is already kind of a lot of stuff to cover. But if we get to the pixels, then we're going to be doing some things using some lesser known parts of the PNG file that you might not ordinarily be doing. So that's kind of our plan. Let's see what we can actually get done as far as that goes. So today we've got our kind of standard getting started. Now, just for fun, I pulled up the docs for this just in case we're going to need them, and I just noticed that yeah, we got scenes. We're just getting carried away here, Cam. So we're gonna operate with this. For basically all operations. Now, basically GPG is already installed on this system, so if I run it, then you'd see that it does things. I think we can probably just, oh yeah, no, you don't get to do that. So we can probably, is it a big V? No, is it a version thing? Yeah, okay, it's GNU style. So I've got this already installed, and the rest of it we're basically gonna get. So you can apt install this. It's pretty much built into Ubuntu by default at this point anyway, so not something you're going to need to worry about. All right, well, I mean, unless you're on another operating system, and you probably know how to install GPG if that's the case. So where are we? Well, we had a lot of fun with the live coding that we're setting up, and that's going to be for people who are interested in learning different languages on stream. We already have a couple people signed up, and I'm not taking any more signatures. No more signups right now until we get the tools sort of like flexed a bit. We know that they work properly. So we're going to be able to see that. You can check back in the earlier streams if you want to see how all that got built, but we went crazy with multiplayer editors. So this is episode 4. Let's just get this party started. All right. Now, we're not going to need a lot more to do this other than, we're just going to need our standard like Python boilerplate to get going. So I'm going to say that this is just going to be like digital signature craziness. So we're going to call this dig sig because I'm digging sigs right now. So we're going to dig sig and get ourselves a virtual environment, and we're basically kind of good to go there. So now I'm going to need a few tools in order to do this. So let's, we don't want Python, we want to install some stuff. So let's get Python GNU PG, and that's all fine. Just in case we get that far, we're going to need Pillow later as well. And I think that's probably all we're going to need for today. So let's, let's get rolling. So Freeport dude, I still haven't gotten a hold of him, but so what we're going to do is we're going to take this and we're going to be able to run digital signatures, and right, that's all wonderful. So the first thing we're going to need to do is we're going to need a place to operate. So for this example, I don't really have anything in here, so let's make our not great vault. So let's say that our not great, well, our vault is going to be in apps S1E4. You need a full path for this. Not great vault. Now I'm going to revoke all the keys that you're going to see a little bit later, so after the show. So don't go too far with all of this stuff. But we will have, we're going to operate in this directory, which doesn't exist, as you can see. So not much has been done ahead of time. Now, okay, so what we're going to need is, we're going to need like a few basic things to be able to operate easily on these files. So we're going to be using OS and showutil a little bit. So let's use OS in order to make the directory. And actually, you know what? Let me not put that in main. Let's init the vault. So let's do that instead. So let's init the vault, and in here we're going to make some dirs, and those dirs are going to have, we're going to be focusing on the vault, and because it's GPG and you really should be using octal, which the Primogen discovered last night in C would normally be specified. Like say I wanted like file permissions like this, then you just do this in C, you put a 0 in front of it, but in Python you need the O as well. So we're going to make that so it's only readable, writable, executable by us. And we're going to, no, don't worry, I'm not going to revoke all the keys, Nightshade, dude. I'm going to leave my key, which actually, you know, I'm glad you asked, because that's my fingerprint. So I'm just going to leave that up in the corner because we're feeling kind of key secret-y today. So you can, we'll get to that a little bit later though. So don't worry about that QR code quite yet. All right, so, and then we're not going to worry about if this thing already exists, because we're probably going to be running this program and blowing away the key store a bunch of times. So, hey, what's up, Akshay? How you doing? Just getting started here. We're making up our vault, and if we're run here, we're going to want to blow away the vault in case we're reinitializing it. So let's just make sure that the vault here is not there, but just in the event that you know, it's the first time we're executing this program and there's nothing there, just ignore the errors, and that should be fine. So right now, if we run this program, we don't get very much other than an error. It's not ignore error, it's ignore errors. And OS doesn't have makedir, it has makeDirs. And exist does not exist, it's exist, okay, all right. So we're gonna get our plural cases wrong, and that's gonna be fun because it's live code. Okay, so in here, let me just get this out of the way. We have a not great vault, and there's nothing in it right now, but we will reinitialize it, so we can sort of run this program as much as we want, and it'll just keep on blowing away whatever's in there. I mean, I can go in here and say, no, don't delete, and there it is. It's no, don't delete, but if we run our program, I'm sorry, it's just not there. Okay, so we're ready to operate, and in order to do any of this key stuff, we're going to need to pull in GNU PG. So this is the Python GNU PG that we just installed. So we're going to need that, and there's an object on there which is GNUPG.gpg, which handles sort of all of your initialization. And it needs a home, which is the vault that we just created. And that's basically, it's going to not operate on my keys, which are in some directory somewhere. Instead, it should be operating on this little vault that we just created. So this is where we have to start being careful about leaking key secrets on stream. But we'll see how many times I fall for it. And I'm just in case, I'm going to drink a little coffee to make sure that we're caffeinated. Okay, so all right, we have this thing, and we need to be able to generate a key to put in there. So that's not too hard with GNU PG. So you basically just, we're going to end up with the key. Well, let's worry about that in a moment. So the routine we're going to need is the gen key input. So this is going to get kind of our parameters set up for how we want to initialize the GPG vault. So we're going to say that our real name is the Nightshade dude. No, okay. Let's work with user A and user B and all that. I guess if we're using the traditional applied cryptography, it should be Alice and Bob and all those names. But I'm not going for that level of security on a stream. But yeah, I know it's there, Nightshade dude. Sorry about that. And so we're gonna need Nightshade's dude's email, which is nightshade@dude. No, wait, that's totally wrong. Okay, so we're gonna have user A at example.com. So let's not hurt the innocent. And we're going to need whatever GNU PG password we're going to use. So I was thinking about this long and hard before the stream, like what password would we want to use live on stream? And then I realized, like, let's just talk about the facts, okay? Because Chrono Trigger is the best game ever. So we're gonna start with the truth, okay? And from there we're gonna move on to other things. So basically numbers station. No, but we're gonna be generating numbers ourselves, so don't you worry about that. So I've noticed the programmatic streams seem to do very well, and my theory there is just like people want something to watch, and live coding is hard, so they're just kind of cleaning up to everybody else. So this should create our well, we've sort of configured our key input. So now we actually have to get a key. And the way we're going to get the key is we're going to generate it. So no real surprise there. And we just pass along kind of our config that we just generated. So if all goes fine, we should end up with a key. Now, the key has a bunch of stuff on it, but we're going to talk about that in a moment. So now this starts taking a little while because it's going to start hitting the high quality entropy pool, and we're going to have to watch it. Now the thing that gets dumped out here is, excuse me, this is the fingerprint for our key. So if we just wanted to be like precise about it, it's actually hanging off of the fingerprint parameter. So that's the string, and I could say like, user A fingerprint is going to be this thing. Great, so that just blew away the vault, and we generated a new key, and that's all fine. It's going to blow it away every single time I run this program. So that's pretty good, right? That's our base vault code. So this basically gets us started to be able to sign and encrypt and everything else that we're going to need to do. Now, for purposes of operating around here, we're going to need another user that we're going to need to know about. So prior to this, I created a user B. So we're gonna go find our friend here, and we're just gonna pull him in because I think I left it over here. And nope, I didn't leave it over here. So I think that I left it. Right. I think it's in this setup directory and some other stuff. That's for the episodes, and we're in episode 4. And yeah, okay, I did leave it over here. So I'm just going to copy this key over. So we're going to need that in a little bit. This is for just some user that you found, like you met in real life. This particular user is not very creatively named. He's named user B. So we'll worry about user B in a moment. So let's see. Do you know about the oh, sorry. That's yeah. I already responded. Did I forget to respond? Yeah, that's Oh, you're talking about like the real ones. Like yes, I have actually heard of that. There's like one over in like the Ukraine or somewhere. Yeah, it's some mystery that's been going on. There's kind of a mystery. Well, anyway, I don't want to get too far afield. There's actually a lot of stuff to get through. So, right, we have our user here. Now, I can keep on generating this as many times as I want, seemingly, until I start running out of entropy. And you're going to notice that if I watch, so this is in proxys kernel random. If we go in here, we have a whole bunch of things about the current entropy pool that's available for this program. And that's how much I have available. I had to kind of stock that pool up before we got going today because we're going to need a lot of randomness. So we want to keep an eye on that. So I'm going to just over and over again look at what's in the entropy pool. So let's do that. All right. So up here now at the top of the screen, we can see like how much entropy is available at any moment. Now I'm going to just keep that permanently up there. So we're going to resize. That's too big, isn't it? So we're going to resize this to be like 5 lines. Okay, so you can, oh, we can actually go 1 line further. We can resize it to 4. All right, so you can keep your eye up there, but as we're operating, you're going to notice this entropy pool is going to start diminishing. So like for example, if I just blow that away and I just start generating and then I blow away and I start, okay, wow, oh, that's right, I ran the entropy daemon. So we should be all right on entropy for the rest of this show. We'll find out. Okay, now we don't actually want to blow our identity away every single time we run this program. We want to try to make some progress. So, man, everybody on the internet with that virus can watch 5 seconds without buffering. Yeah, it does seem like the internet has been struggling a little bit. So, and by the way, nice icon, Nightshade, dude. That is totally basically what I drew before. So, right, we've got our vault. Now, in order to move around from the vault, we're actually going to need like some stuff that we can play with. So, we could start talking about cryptography itself, which I told you today I'm sort of less interested in. But the first thing that we're going to need is let's see what it's like to deal with multiple users. So let's get user B. Let's import another key, right? And this is something that would have been passed to you in some secure manner. We'll get to checking that later. But let's say that we want to import this file that I just copied over, this userb.asc. Now you can generate your own basically right here by just showing it. So like I'll show you a little bit, but we're going to operate on userb.asc at the moment. And this is import file. And what we can do here, I'm not going to display that one, but let's take a look at what we actually just created. So let's say that this routine runs. So the first thing we do is we open our vault, and that's going to get every single routine we write. We're going to start there. And then we want to see like what keys are in there. So we're just going to dump that out. And there should only be 1 in there at the moment. Okay, there is. So the key that I just created for user A example, so I didn't clean that up. I should make that pretty for all of you. Okay, so my apologies. It's just one of those days. So here we have the user A key that we just created. This is us operating on the trust store, and we know what our fingerprint is for the key that was generated. Now, this say we go and we send some of this key data, like to actually like get the key data, we would need to dump out the the public key material, and that, yeah, like that's sort of hidden, tucked away in a different file. We're not gonna worry too much about that. That's over here on when you're exporting, public stuff. So like we can export keys. This will actually give us an ASCII armored version of the key that we want. So say we wanted to dump ours out, and hopefully I don't dump my own one out, but let's actually do this. So because why not? So let's go and dump out the user A this was usera@example.com. You can use any key identifier that GPG recognizes. So in this case, I'm just going to use the email address, and we're going to not, yeah, we're not going to output that other stuff. So there you go. There's the public key block. So this is our first public key block. Great. Well, user B went and did exactly that before the show. Good thing user B did that. And we ended up with user B's public key block. So let's go pull that into our key store so that we can start doing some more interesting things. So GPG, and this is pretty straightforward. I really like this library. This is a wrapper, and the author did a nice job of sort of making it as convenient as possible, given that GPG, it's kind of like not really a library. I think he's operating on the raw executable. So all we really need to do is basically read in this key. So the key file is in this imp file. So if I want to read this thing in, not that hard, so I can say like user B pub key is that. Then I can go here and user B pub key, I can go and import it, and I should get a result to that. So let's see how we did. So we go and run that, and yeah, we get the result object, which I forget what parameters there is on it. It's one of those like, yeah, okay, results. So results and that. Okay, so this is great because it basically is saying that we pulled in this key which had a different fingerprint, because this is user B's fingerprint, allegedly, and it's, you know, telling us that it kind of like pulled the thing in. Now it's not importing it again because I already have it imported because we've run this program multiple times. But if I blew the vault away and started over again with a fresh identity, yes, okay, so here we're pulling in an entirely new key. Now this is good because we managed to get an okay, and we don't have trust configured right now because we've just pulled this thing in, but we don't really know that we can trust it. Now, I don't want to talk too much about trust. Basically, you need some method of verifying that this fingerprint is right. So, you know, that could be preferably in person, and, you know, they have key signing parties. There's all sorts of ways. Say you could wrap it into a QR code, which might be hanging out over there. You have different ways that you can pass around trust, and you're going to need to kind of make an assessment based on how you got this trust. Was it interfered with? How much can I trust this key that was just pulled in? I'm going to skip that. We're just going to pretend that we know that this is good, that this was the right fingerprint. And I can tell you that, you know, when I generated the thing, I came up with this fingerprint, and we can go, oh, sorry, wrong key. Oh, yeah, no, sorry, that's the right key, right? So I got this fingerprint when I generated it earlier, and we could see that these things are, you know, the same if we check them very carefully. Okay, so we're just gonna say like, yeah, let's just trust this user. So to do that, I noticed that there were problems. There is a routine in here called trust keys, which, you know, it pretty much gets invoked the way you think, but the problem is that didn't work. So I actually ended up just trusting this thing, you know, when I was doing prep at the command line. So I can actually run GPG directly if I tell it to operate on the key store that I just created, which is not a great vault. I was working in temp earlier. And I think I need to give this a full path, actually. So let's just give it a full path. And then what we need to do is we need to edit this key. So this was user B that we just pulled in. So there it is. We have user B was pulled up, and we don't really know anything about user B other than, well, GPG doesn't know anything about user B other than, you know, here's some key material about like which ID it is, and, you know, when it was created and how long it's valid for and whatever. We don't really know much about this user because I made very basic keys for this. Now, that's great, but we want to see what the fingerprint is. All right, so we take a look at the fingerprint that is attached to the key, which surprisingly matches the fingerprint that was on the keychain and matches the fingerprint that I had at generation time. So we verify that, we go, yep, that's all fine. I want to trust this key. Now, there's some issues here if you don't trust it ultimately. In this case, I do trust it ultimately, but you probably just want to trust it like fully or marginally for most uses. Okay, so do you want to give this ultimate trust? Yes. Okay, now if I go looking at this key, let's say we just edit this key again, you'll notice that it's been added to the trust database. So this GPG will now trust that this key works properly. That's important because it will break your code. You'll get some invalid, where was it? Let me tell you exactly what you're going to get in the event that you forget to do that and you try doing this again. You're going to get this invalid recipient. It's not that the recipient's invalid, it's that the recipient's untrusted. So the program's just going to kind of reject it. So yeah, this is, that's great. So now we have our own key, we have our other user, and we're ready to start operating. So as far as this part goes with exercising our code, we're going to say that we've done this. So we're actually, let's get more direct about that and say that we've done this. All right, so we've exercised this. We know that we're good in here and we've trusted it. And now we're ready to start signing and verifying. So this is, yeah, I can't draw that, like barely holding it. So let's just work here and get this thing signed up. All right, so this is, now we have our other key in the store and we're going to stop blowing away the key every time. Great. Have fun, Lightshade dude. That's might be difficult remotely. And yeah. So wonderful. Well, turns out we should try signing and verifying. So let's sign and verify something. We're going to need something to actually verify, but for now I'm just going to do some simple strings that are operating in memory. So we're going to sign and verify. And what we're going to do now, in the case of the two keys that I have in there, I have the public key from user B, and I have public and private for me, who is currently user A. User A can sign things, but user B, I can't sign for user B unless I had their private key. That's kind of important because if I could sign with their public key, we'd have some issues. That's sort of a different operation. So we can send something to them that we want only them to see, but we can't sign, we can't pretend to be them. Okay, but we can be us. And so to do that, let's reopen our vault and we're going to have a very amazing variable naming here. But let me just, yeah. Okay, I don't want to get too much into, that's a little bit complicated, but let's start with a basic signing flow. So say I want to sign something and I can pass along, there's a variant to this, which is sign file if I want to operate on files, but I want to work in memory. So I just need something that I want to sign. So Nightshade dude is teaching a new hire. So let's say that this is something that's really important that you all know that I signed this. All right, so there's our message. Nightshade dude is teaching a new hire. Well, that's good. Now we need to know, in the case that I'm signing, well, actually that's it, right? It's going to pick my default identity and it's going to say, well, you're user A. So you mean that you want user A to sign this thing? Yeah, okay, well, let's see what we get. Now, if I go and run my program again, now I'm going to be prompted for my program. I don't know if you can see that on the stream, but I'm getting a screen that's asking me to say that Chrono Trigger best game ever. And if I type that in right, I get my signing message, which is Nightshade dude is teaching a new hire, and I get my signature, which is kind of neat. Now, this is signed with user A. So how do we know that that's fine, right? So let's take the contents of all of this. Now, I could actually just write it out. So let's do that so that we don't mess with it. So let's open first text, and this is going to be a signed file, but we're not going to worry about extensions. So we're going to write out into this first text the contents of this signature. Now, GPG operates whether it's binary or text, so it sort of assumes that everything it's dealing with is binary. So let's try to keep to that for now. Oh, I actually need the payload there, which is, I think I can just coerce it. Oops. So if I ask it to be a string, but strings need to be encoded as binary, so I know that this is in the ASCII domain. Yep, this works. So I can look at first text and I get the proper message. And that's going to work binary or ASCII, as I won't have to do the encode step because it'll actually be binary. I just flipped it into bytes by doing that. So great. We know how to sign. Now, do we know how to verify? So that's going to sign for us. Now, this part we can actually just stop doing that. So the thing that we want to do next is we're going to want to verify. So again, I'm going to show you the memory version of this first. So let's take B here, which is going to be our signed text. I'll name the variables a little bit better. So we're going to take our signed text and we're going to open it up, which is the first text. Again, we're going to go with binary and we're going to read the whole thing in, and we're going to ask GPG to verify this thing. So now anybody who has the public key for user A can verify this if they trust the key they have for user A. So this is going to give us a verification result, and I'm going to print that out, which is actually just an object, I think. Yeah, we actually get the verify object. So to know that this is fine, you just cast it to a bool, and it'll do the right thing. Okay, so actually it worked, right? So we know that this signature on this file is good. We can prove that by screwing with this file. So say I go and I edit this first text because I'm a bad person, and I want to say something that wasn't said. Is teaching a new hire. Maybe. Okay, so I've gone and I've changed this message. So I run this thing. Yeah, that digital signature fails. Okay, so our basic operations work fine. Now, like I told you, there's a file version of this. I don't actually have to read the thing in and then do it in memory. That's going to be useful in a moment. But for now, let's operate on that file directly by saying GPG verify file. And this just expects a file-like object. So we'll just pass it the open. So let's say first text as binary and stick that in the result. And we already, okay, it's not valid. Now that's because I went and I changed the text. Theoretically, if I get that right to exactly where I started, the signature passes. I mean, even one change here is going to screw this up. Okay, so we know that our signature stuff works great. Except I don't want to leave that in a broken state because it's depressing. So I want to see that that signature is valid. Okay, good. Now we have signing and verification. So we're actually, damn, we're cooking. So that's pretty solid. So just because I think we're going to be in reach, let's go for it. I mean, that was our sign and verify. So we're good there. I'm giving a nice big, you know what? I'm going to get even crazier, and I'm going to say that I get a green check mark because that's a pretty dark green. So I'm going to take this green. Yes, that's a big check. All right. Well, that just leaves one more thing that we have to do, and I didn't think I was going to get off that easy. So we're going to have to go and do this with our pixels. All right. Now, this is where things get a little interesting. So that all worked fine. So we're going to get to our pixel fun. And a pixel fun is going to require some pixels to start operating with. So let's just set that up. And all right, so we're running that, nothing really happening. To do a little bit of pixel fun, we're gonna need some pixels to operate on. So back here in our assets directory, I happen to copy Fumiko. Now, who is Fumiko? Well, Fumiko's kind of fun because Fumiko, for those of you, I still have some entropy available, so we're still good to go. Fumiko is a very special sprite to me. Because if you're not aware, Fumiko is the sprite that I used for the Lux Jam. Okay, so this is the character that I was using. This is off OpenGameArt, and this is the character that I was using for the live learn of Godot when I was participating in the Lux Jam, which was like 24 hours and write a game from scratch. Lana talked me into it. I hadn't worked in Godot before. She's like, well, when are you going to learn? You know, so no time like the present. We took Fumiko and we put her into a game world. Now, the game wasn't that fun, so I'm not going to link it here. But, oh, sorry about that. I totally need to get that screen command added. This is, and for those of you who've been here before, you're going to realize that I do that occasionally. Thank you, Yaya. Let me make a note. Add a screen command for the bot. But basically, sorry, this is Fumiko. Didn't mean to show you the whiteboard. That has the, this is what I was using in the game jam. So we're going to take this image and we're going to operate on it. Now, PNGs have kind of a fun hidden side to them. And we're going to talk about that hidden side for a moment because that is important for what we're going to do. Now, we learned up here sort of how to read a signature. Now, in this case, we actually like signed the file and we saved it in the file. Now, if we do that with a PNG, we're going to make the file invalid, right? Because it's going to have like the signature text at the bottom of it, and that's not part of the PNG. So anything that tries to read the PNG is probably going to break unless it can deal with some level of errors. But that's not a good place to store that key. So instead, what we're going to do is we're not going to store the key in the file itself. We're going to store it outside. This is called a detached key. So I basically am going to start off the same way. What I'm going to do is I'm going to read my file in, and I'm going to get my signature. And that's pretty close to what, actually I need the GPG too, don't I? That's pretty close to, yeah, this is my signature right here. So that's pretty close to how you operate on the binary file itself. So this is going to be Fumiko signed sig. In this case, we're going to do a, now, just like I showed you over here with verify file, there's an equivalent sign file. Now, if I just hand this Fumiko, then it's actually going to sign in the Fumiko file, which we don't want to do. So let's not do that. So this won't actually write onto the file, but the thing that I get back is going to have the data of the Fumiko file with the signature at the bottom, which is not what we want to write. So let's tell this system that we want to detach the signature. So in this case, I have to actually like tell it, like, you know, that you need to detach it. Don't put it in the PNG. We want it to operate in a separate file. It doesn't matter if I'm going to read the thing in memory or if I'm going to operate on the disk, same story. If I want that signature not with the binary of the thing, detach it. Okay, great. Well, let's see what we got if we detach it. Now, okay, this string has no object to be read. It's because you don't pass it the string of the file, you pass it the stream that points to the file. Okay, that's neat. I get out my signature block and I don't get all of the binary that's associated with the file. Just because you're all special, I'm going to show you what happens if you forget to do that. And let's say we didn't use the detach here. And okay, this, ooh, what did I actually do with the Fumiko object? Yeah, okay, so there's my normal binary. And we're going to clean that terminal up. And oh, it's in the data, I think. So if I go and I run this, yeah, okay, that's, no, actually that's weird. I mean, before it was actually, no, I guess it's being smart now. But let's stay safe and do it sort of the way we're supposed to. So, okay, yeah. So now I'm getting binary back, and oh no, it might have actually altered the Fumiko file. Yeah, that would be bad, wouldn't it? So let's just take a quick look at Fumiko versus apps, assets, pixel, Fumiko. Oh no, okay, good. It didn't edit it. Okay, so that's weird. I don't know why that was doing that to me in the prep session, but whatever. I think it was trouble. Yeah, I'm not really sure. Oh, maybe because I passed it along as file. Yeah, I mean, if I was operating on the thing as binary, but then I realized like, it's better to just operate on the file directly. Okay, so we have our signature and we're good. Now we need a place to put this signature. So if I just append it to the end of the file, which would be bad, then we would, create our invalid file. So instead, let's go to our imaging library. So for imaging, we're going to pull in PIL, and we're going to need image, but we're also going to need the much lesser known piece, which is I think actually if I just pull in PIL, we're probably all right with that, but pil.png image plugin. So PIL by itself can operate on a PNG file, but if you want to go messing around with things that are specific to the file format, you're going to need the actual image plugin itself. So let's do that. Now, what I want to do first is we're going to actually read this file. So in the case of, just because I want to prove to you there's nothing in there. So if I go and I say pil.image.open, and I specify that this is fumiko.png, so this should be unaltered, then I'm going to get an image. All right, now if I print out the info tag, which corresponds to the iText chunk in the PNG, I'm going to get, it's sort of like EXIF data, I'm going to get a little bit of information about the picture. And that's, right now it's just telling me that the DPI is 7272. Now, what's cool about that is it's not actually EXIF data. So I can go and doctor this thing. So let's say, for example, that I want to like write over it. So this, I don't think I can operate. Yeah, no, you're not allowed to change the the object. So this is probably going to just shallow clone it, which is not really what we want. So let's, well, just because, hey, we might get lucky. let's go and take this thing, and we're going to add a iText chunk. So this is, just in case you're curious, this is the iText chunk in a PNG. Okay, so this iText chunk, here it is in the header, and if I look at iText, then I can see that I can stuff some extra textual information in the PNG file. PIL allows us to operate on this, so we can say like, some stuff as the key, and then we have to give it a value. So here are some things, Okay, great. This isn't actually going to save it because I'm actually going to have to specify that, except it's probably not going to let me operate on the raw info object. Yeah, you're not allowed to operate because this is actually just a dictionary. It's not, I've lost the object itself. So if I want to actually make my own, then I need to do this PNG image plugin, and I need to get a PNG info record. So this is what I'm actually going to doctor. And I'm going to take this thing. Now I could copy over the keys that are there. I'm not worried about preserving the metadata at the moment, but that would be important in general. So if I go and I add text to this thing, so we don't need to do it to the image, we're going to instead add it to our info object. That, okay, PNG image plugin is undefined. Oh, did I? No, because it's PIL, right. PIL PNG image plugin. Okay, there we go. Okay, so we're gonna stop showing this old signature. And right, we see right now that we don't have anything really from the image. There's nothing in there. but I've created a new object that has what I'm going to need in there. So I can actually go and iterate all these keys and add them back, but we're not going to worry about that for now because clock's ticking. So let's go and actually save this thing. So saving an image is pretty easy. We're just going to need a different version of it. So we're going to call this signed because that's where we're heading with it. And we're going to say that this has to be a PNG. So don't try to do the file magic on there. And we can say the PNG, this has like kind of a hidden parameter if you're working on a PNG, which is the PNG info. And I can say use this PNG info on the file. Great. Now I get a new file here, which seems to be just about the same, except it isn't, right? And we'll see that this is just slightly bigger. And the difference between those two, if I open up the other one, is that Fumiko signed actually has, now I'm gonna, here I'm printing out what's in there. So let's not do these things for the moment. Okay, so clear that, run here. Now we see that there's actually some stuff embedded in there, which is pretty cool. What do we want to embed in there? Our signature. So let's get it. So here I have a way of adding text directly to the file. So if I go and I add myself a new key, say sig, right, then this, I don't want to work on the signed one anymore. I want to work on the original. And we're going to overwrite the signed one. Then all I need to do is just figure out whatever signature I want to embed in here. So this will be the Fumiko sig. Now, I have to actually calculate that sig. It comes to me basically the same way that we just did up here. Oh, I already have it done. Look at me naming things consistently. So here we open the file and we generated the sig. Here we're actually taking the sig and we're sticking it in this sig text object. I can say signature. We can spend a few more bytes, right? Bytes are cheap. And we're going to write that out here. So, yeah, sign doesn't have anything called encode. So that's because this is actually binary. Except we know that the signatures are always going to be ASCII armored, so it's fine. You can decode this thing because we know it's ASCII. Because it's just the signature part. Oh, sign object, right. I actually have to cast it. Oh, now I don't need it because it's already cast. And it does the work for me. Great. Okay, so this was the old, info that was in there. But now if I load up the signed version, and I don't edit it, so I'm not going to save over it. There we go. Embedded signature inside the image, and it's just hiding there in plain sight. So I've got my Fumiko signed, which is now a little bit bigger, and I shouldn't have changed the file for the viewer. So if I come back here to my browser, there it is. To actually verify this signature is a little bit more work. The thing that we are kind of playing a little fast and loose with is the fact that writing out this PNG file again. So I took this PNG, I read it in image, or sorry, not in Image Magic, in Pillow, and I then went and doctored the table and I added the signature to it, and then I wrote it back out. But the problem is that it's not exactly one-to-one. It's not idempotent in this case because Fumiko, if I took Fumiko and I wrote Fumiko directly out with no modifications, it would probably be different. Unless this author was using exactly the same version, then that's going to be problematic. So this signature that I signed, which was signed against the original binary, is going to cause trouble. So to fix that, I would have had to pre-encode it with PIL and make sure that I get exactly one-to-one for my output, except now it has the signature attached to it. So verifying the signature would just be pulling the file open, removing the signature, and checking that against to make sure that it matches. So there you go. We have a file that we can send with a buried signature for user A to Lanalux. So I thank you for tuning in. Thank you for checking it all out. I'm going to go and give myself another check because it's just that kind of day. And yeah, come by for the free code sessions where things are less prepped, and come by for the learn sessions. There's also going to be, there's a few sub-segments that are going to happen. So this is just our regular Friday segment where it's more about like, you know, doing our typical, you know, compact sessions, right? So this is about like, you know, can we give you something dense in an hour? But in the case of the other sessions, they're more like 2 to 3 hours. They're a little more, you know, I assume people have time who are coming to check it out. And that's, yeah, you know, feel free to see what you want to see. So anyway, come join us on the Discord. We can chat. I have a, just for anybody tuning in late, there's the Discord. So, you know, the SumBot is in there as well and has a whole bunch of commands that'll tell you like, you know, what kind of keyboard it is and all sorts of other fun stuff. So real fast, any questions, everyone? No questions? Yeah, that's exactly the idea, Cam. So, oh, actually, I see that Lana's on. So we could actually probably drop in on her and tell her that we have a special picture for her. I don't want to, let's not drop it in chat, everybody, but yeah, let's go do that. Let's go visit Lana. So thanks everybody for sticking around, for checking out the raid, if you're going to stick around for that. And yeah, thanks for coming. And there's all sorts of fun little things that you can do with this, which I'm not going to go into too much detail. So I'm going to go back next week. We're going to get the rest of the dev tools ready to be able to do live lessons on the stream. So we'll have the CSG live show. Should hopefully be, it might be a little too early next week, but coming up soon. And then after that, yeah, I mean, we got games to write. We got more fun to do, and I'm going to get the season schedule out at some point. So we'll get to all that. But anyway, thank you very much for your time and have a good day. And let's go check out